Hi everyone, myself Mrs. S. Nusrath Najeeba, Assistant Professor, Department of Computer Science SF, the Standard 5 Works, Rajaratnam College for Women, Sivahasi. In this video tutorial, we are going to learn about structural constraints in ER model. In all the previous videos, we have learned about what is a DBMS and what are the data models in a DBMS. Through this video, we can learn about the structural constraints in an ER model. These are the contents that we are going to cover in this video. First one, you have to see the introduction of a structural constraint, then the types of cardinalities and participation constraints, and final conclusion. That is the overall summary of structural constraints in ER model. Let's go with the introduction. First of all, let me see what is a structural constraint. Structural constraints within the context of entity relationship, that is ER modeling, specifies and determines how the entities take part in the relationship, and this gives an outline of how the interaction between the entities can be designed in a database. There are two primary types of constraints are cardinality, that specifies the number of instances in a relationship, and participations, whether all or some entity instance are involved in the relationship. First, let's go with the cardinality. Cardinality is defined as one to one, one to many, or many to many, while participation can be total or partial. This forms the constraints that need to be used in defining an accurate and efficient database schema, since the introduction of the interaction rules of entities ensures that the correctness of the data model reflects in the real situation. The knowledge of these constraints is very essential for the design of strong and functional databases. To understand structural constraints, we must take a look at cardinality rectangle and relationships by diamonds. There are numbers represented as written above the lines which connect relationships and entities. These are called cardinality ratios. These represent the maximum number of entities that can be associated with each other through relationship R. Next, we are going to see the types of cardinality in ER model. There can be four types of cardinality, that is one to one, one to many, many to one, many to many. Let's see each of them in detail. First, we see one to one cardinality, that is when one entity in each entity set takes part at most once in the relationship. The cardinality is 1 to 1. Next, 1 to many. If the entities in the first entity set take part in the relationship set at most once, and entity in the second entity set take part many times, at least twice, the cardinality is said to be 1 to many. You can see in this diagram, we are having two entities, that is E1 and E1. In this, the first E1 is connected to the entity, the first entity in E1 is connected to the first three entities in the another entity set. This relationship is called as one to many cardinality. Next cardinality is many to one, that is n is to 1. If entities in the first entity set take part in the relationship set many times, at least twice, while entities in the second entity set take part at most once, the cardinality is said to be many to 1. The next cardinality will be many to many, that is n is to n. The cardinality is said to be many to many if entities in both the entity set take part many times, that is at least twice in the relationship set. Next we are going to learn about participation constraints in ER model. In DBMS, that is database management system, participation constraints are rules that govern the minimum and maximum number of entities or relationships that must or may participate in a particular relationship. Within the database structure, these restrictions uphold business standards and guarantee data integrity. Comprehending participation limits is essential to creating successful and efficient databases that faithfully replicate real-world situations. Constraints on participation are essential for preserving the integrity and consistency of data. By imposing business rules and restrictions, they contribute to ensuring that the database appropriately reflects the real-world scenario it models. Database administrators can avoid errors and inconsistencies that could result from missing or inaccurate data by specifying these limitations at the database design stage. Also, database normalization, a procedure that reduces redundancy and dependency in the database schema, is impacted by participation limits. Through the definition of participation limits, designers can pinpoint connections and enhance the schema structure, resulting in enhanced database system efficiency and simpler maintenance. Participation constraints in database management refer to rules that determine the minimum and maximum participation of entities or relationships in a given relationship set. While partial participation permits discriminatory involvement, total participation requires every entity in one set to take part in relationship in another set. By maintaining consistency and enforcing business standards, these restrictions guarantee data integrity. For example, in a college database, partial participation would permit courses with no enrolled students, while entire participation might require all students to be enrolled in at least one course. For database schemas to effectively replicate real-world circumstances and enable efficient data management, it is imperative to comprehend and include participation limits. There are two participation constraints in DBMS, such as total participation and partial participation. Okay. Let's see total participation. Total participation means entire participation. Sometimes it is referred to as required participation, that denotes the requirement that each individual in a group participate in an activity pertaining to another group. It is similar to saying that in order to belong to one group, you must somehow be associated with another. In a university database, for instance, total participation between courses and students indicates that each student is required to be registered in a minimum of one course. It follows no student can be excluded from a course. It serves as a means of guaranteeing that every member of one group is connected to something within another, ensuring that nothing is overlooked or left disconnected. In the below diagram, the participation of an entity E in a relationship set R is said to be total if every entity in E participates in at least one relationship in R. The participation of entity set A in the relationship set is total because every entity and the participation of entity set B in the relationship relationship set is also total because every entity of B also participates in the relationship set. Next, partial participation. In database design, partial participation is also known as optional participation. Allows certain aspects of a relationship to be optional. It implies that the way the database is configured does not require that every entity be linked to every other thing. Consider a database at a university. For instance, partial participation can mean that some students are enrolled in classes but not all students are registered in them, because it recognizes that not everything in real life is always connected to everything else. This flexibility is crucial. While some objects are connected to one another, others may stand alone. It permits scenarios in which certain database entities may not be connected to any other entity. In below diagram, the participation of an entity set E in a relationship set R is said to be partial if only some entities in E participate in relationship in R. The participation of entity set in the relationship set is partial because only some entities of A participate in the relationship set, while the participation of entity set B in the relationship set is total because every entity of B participate in the relationship set. In this diagram, we can see that A4 doesn't participate in any relationship set and B5 doesn't participate in any relationship set. Therefore, the both entity sets A and B are said to be partial. Okay. Example, suppose an entity set student related to an entity set course through enrolled relationship set. The participation of entity set course in enrolled relationship set is partial because a course may or may not have students enrolled in. It is possible that only some of the course entities are related to the student entity set through the enrolled relationship set. The participation of entity set student in enrolled relationship set is total because every student is expect to relate at least one course through the enrolled relationship set. Let's see a good summary of structural constraint. Structural constraints that are also called structural properties of a DBMS, that is cardinality ratios and participation constraints taken through are called structural constraints. The name constraints refer to the fact that such limitations must be imposed on the data for the DBMS system to be consistent with the requirements. The structural constraints are represented by min-max rotation. This is a pair of numbers m, n that appear on the connecting line between the entities and their relationships. The minimum number of times an entity can appear in a relationship is represented by m, whereas the maximum time it is available is denoted by n. If m is 0, it signifies that the entity is participating in the relation partially, whereas if m is either greater than or equal to 0, it denotes total participation of the entity. Similarly, a book of the library system either borrowed or not by a member, a partial participation in the relationship of book with member. The partial participation captures even more fluid scenarios wherein not of all the entities are involved under an obligation to participation in a relationship. I hope you have learned what is a structural constraint and types of cardinalities and participation constraints through this video lecture. Thank you for watching the video.